So now I want to talk about distance supervision for relation extraction. Relation extraction, the reason that it is challenging, for example, in biomedical texts is because labeled data is expensive, it's hard to capture, especially for domains that nobody talks, such as biomedical texts. That's why we have two paradigms to get around this problem. One of them is distance supervision, the other one is zero-shot learning. Distance supervision uses a knowledge base. For example, in common sense reasoning, we use ConceptNet and Atomic as our knowledge bases. And zero-shot learning is just a restriction of few-shot learning paradigm. So it's another paradigm. And I have a playlist for few-shot learning that you can understand, because you can get around the problem of deep learning, such as because deep learning needs lots of data, it's data hungry, and so few-shot learning allows us to use just few examples. So in relation extraction, we mainly use distance supervision, but the problem of distance supervision is that we don't have access to knowledge based, and sometimes we don't have access to that because it's expensive. So that's why we go talk about zero-shot learning. And he's an amazing scholar. So there are lots of articles that talk about distance supervision. There are lots of more distance supervision articles, and because if you use distance supervision, you don't need to label manually lots of things. You don't need expensive crowdsourcing, and you can do tons of data with just for tons of data. You can use your knowledge base and do it very quickly. It's amazing, but it creates some noisy labels that I will talk about it later. So how about heterogeneous distance supervision? Because sometimes you go from the scope of a sentence to a text to tons of text. So there is so you should work on that as well. So the problem of the supervised relation extraction is that labeled training data is expensive to produce and thus limited in quantity. The relations are labeled on a particular corpus. The resulting classifiers tend to be biased toward that text domain. So the idea is that our experiments use Freebase, a large semantic database of several thousand relations, to provide distance supervision. So we find all sentences containing those entities in a large unlabeled corpus and extract textual features to train a relation classifier. So the intuition of this distance supervision is that any sentence that contains a pair of entities that participate in a known Freebase relation is likely to express that relation in some way. So these are relation names in the Freebase, the knowledge base. And these are the largest Freebase relations in terms of frequencies. And so the open question is, what is the effect of syntactic information and distance supervision? For example, how can we add some features, some syntactic features to improve this state of accuracy? But we don't talk about it today. So the architecture in this article is that all entities, first of all, we do it in two steps. In step one, all entities are identified in your text. And if a sentence contains two entities, and those entities are an instance of one of our Freebase relations, features are extracted from that sentence and are added to the feature vector for the relation. But the problem is it's noisy. If you go from training to test, you will see that. For example, here, this sentence, it doesn't mean we don't like it, but because distance supervision doesn't know which entities to care about, so we have a problem about. So we have some problem. We have some approaches to deal with this noise that I will explain in the next lecture. So there are lots of noise reduction articles, and I think I will explain this one. So good old-fashioned features like lexical features, we go to neural approaches. So nowadays we don't do like this, and we use neural features. So first we create name entity tagging because it's a good way of creating features, and we use feature conjunction. And these are examples of high weight feature for several relations.